Okay, good morning. Welcome to
Family Math number 1144.
Math 1144. So today we're going to try to calculate the area of the Koch snowflake, sort of following up our exercise yesterday. What did we find yesterday?
We found that the perimeter of this, if you do this infinitely many times, this process of adding triangles, the perimeter becomes infinite.
Okay, so we may as well stay with the same example as from yesterday, where the original equilateral triangle has side length 9. Before we dive into this calculation, I'm asking you this on the spot. I probably should have asked you this before we got started, but I'll ask you on camera to come up with a plan. What's the plan that you think we should follow to try to determine the area of the infinite Koch snowflake?
Well, we should try to maybe do it for the first few steps. Maybe try to calculate the area for the first few steps, and then maybe see if there's a pattern somehow, like the amount we're adding on every time, if there's a pattern, and then maybe sort of find an infinite series for that, and then we can calculate it to infinity.
Alright, that seems like a really good idea. So let's find the pattern. So step 1, with just the equilateral triangle with side length 9, what is the area?
Well, so you have 4.5 here times 4.5 root 3. Or 9 times 4.5 root 3. Because you have a 4.5 root 3, 9 triangle.
Okay, so you're saying this is, I'll call it 9 halves, and then 9 root 3 over 2. That's
Yep.
the height. Okay, so what's the area?
81 root 3 over 2. Or 81 root 3 over 4.
Why?
Because you have 9 times 9 root 3 over 2 over 2.
Okay, so we got 81 root 3 over 4. Alright, that's great. And you said you want to just find the area that we're adding on each time, which is fine, actually.
Okay.
So we're going to do this plus, alright, what is in the second step? What are we adding?
So we have
on?
3 triangles this time, of 3 equilateral triangles, where the length is 3. So we have 3 times 3 root 2 over 2 over 2. So it would be 9 root 2 over 4 times 3. So 27 root 2 over 4.
Okay, so we're adding on 3 triangles. 1, 2, 3, and they're all 9 root 3 over 4 area?
Yeah.
Okay.
Alright.
Okay, so we got, that's nice, because these ones are side length 3. Okay, so 2, we've got all this, plus what are we adding on here? At the third step?
Well, let's see. 2, 4, 6, 8. So we've got 12.
Alright.
Times, now these triangles have side length 1. So we have 1 times root 3 over 2 divided by 2.
Okay.
So root 3 over 4.
Alright, that's great. And then maybe we can even do the fourth step. So we got whatever we're adding on. We
So
got our previous area, plus we're going to add on how much here?
Well, looks like 48 triangles of.
Okay, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
You missed this one here.
Let's see, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Times 3, so it's 48.
Alright, so 48. Good.
And then the lead length, a third, so a third times, a third times 3/2
Okay.
divided by 2.
So, a third times. Can you just check that I'm still on camera?
Yep, you are.
Okay. So a third times a third √3/2, and then half of that.
Yep.
Okay. Great. All right. So good. So let's move on to the next video now and see if we can find a pattern.